All right, binomial theorem. Basically, binomial theorem is used to expand binomials without having to do a whole bunch of long multiplication. FOIL, 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 FOIL. So if I need to expand x plus y to the 8th power without having to do that. Now, in order to do that, in order for that to work, we have to use combinations. Now, you recall from Algebra 2, we have things called combinations and permutations, right? Different ways of looking at numbers. If you take prob and stats, we do that quite a bit with combinations and permutations. But basically, combination is a counting method. How many different ways do we do something? Combinations are when order does not matter, but permutations are when order does matter. One way to remember that is that your lockers are named incorrectly. The locks in your lockers are named incorrectly. They are not combination locks. They are permutation locks. From a mathematical standpoint, that's the way it should be named. Because let's say your combination on your locker is 24, 11, 35. Okay? Let's say that's your combination. If you do 24, 35, 11, is it going to open? No, the order matters, right? When you do your lock, that makes it a permutation, not a combination. For combinations, order doesn't matter. Okay? So for example, if I had to pick 3 people in class, and I picked Joe and Bridget and Connor for an experiment, and they were just going to go and get to eat all the M&Ms they wanted. Okay? It doesn't matter if I pick them in the order Joe, Bridget, Connor, or Connor, Joe, Bridget, or no, that wouldn't matter, would it? The order in which are chosen doesn't matter, it's just the 3 that got chosen, and that's a combination. So that's the difference between combination and permutation. Combination is found using the formula n, combination of n, choose r. The formula for it is n factorial over n minus r factorial, r factorial. We don't need to remember the formula, but that's it. That's how we do it. Generally, we do this. We use the probability button on our calculator to find the combination of something. Number of different combinations there are. And if you have one of these calculators, this is the PRB button. First, you put in the total number there are. So let's say we have 9. Well, how about we got 4? How many students do we have in here? 4, 9, 10, 11, 12, 15, 16, 17, 18, 19, 20, 21, 22, 23. We have 25 students in here. I need to choose 3. So I do 25 PRB, and we'll choose NCR, C for combination, and we're going to choose 3. There are 2,300 ways to get 3 student combinations out of 25 people in this classroom. If I had to pick 3 students to eat all the M&Ms they could possibly ever want.
So how does it type that in? N, the
top number, the top number, the first number, the total number in the group is 25. Then the NCR button, and here, that's PRB, and the second choice is NCR. On a graphing calculator, I gotta remember where it is. Hold on. Whoop, I got one here. On a graphing calculator, probability is, I just gotta remember. Math. Math, PRB, NCR. Math, arrow all the way over to the right column, and third choice down. So it's going to bury it a little bit. Yours says what?
There's 2 for each argument. You're going to show how I found that.
Oh, okay. Because yours has to be. Yours has to.
Yes, that's okay, that makes sense. Combination and that's permutation, that makes sense.
You're gonna do that.
That's N, that's odd.
25, comma.
My calculator doesn't like to work with things, it wants to just assign multiple functions to every single button. I got this exactly because it's able to do things really nicely.
Wow, that's complicated. Okay, do not get a TI Inspire. I'm too confused by it. I am not smart enough to figure out that calculator.
Well, you just did.
Well, I knew what it had to do, but I had no idea where the menus and stuff were. So anyway, that's how we do combinations. Make sure you know how to do it because you will need to know how to do that for this. Pascal's triangle, you may recall, is a neat little thing. It's got ones on the outside, and notice that it's kind of works this way, all right? The sum of these two numbers gives me that number. The sum of these two numbers gives me this number. The sum of these two numbers gives me that number. The sum of these two numbers gives me that number. The sum of these two numbers, see how that works? It's nifty, isn't it? You know what's extra nifty about this? Is this is a combination of this is combinations, essentially. Okay? If I do the combination of 0, choose 0, that's 1. If I have combination of 1, choose 0, combination of 1, choose 1. Combination of 2, choose 0, 2, choose 1, 2, choose 2. Combination of 3, choose 0, 3, choose 1, 3, choose 2, 3, 3. So I could rewrite Pascal's triangle instead of with the numbers, with combinations. I'm sorry, 1, 0. Don't do that. Okay, so I could rewrite the triangle, I'll get the exact same numbers. Those numbers are the combination numbers. So, for example, here, I have 1, 2, 3, 4, 5, 6, 7 numbers here. So this is the 6th row. So this number is the combination of 6, choose 0. Combination of 6, choose 1. Combination of 6, choose 2, etc. 6, choose 3, 6, 4, 6, 5, and 6, 6. Why? Because we always start with 0 as a choice. That's why we always get one more combination than the number of items we have. Because I can choose all the way from 0 to all of them. But notice a couple interesting things about combinations. They're always good to know. Combination of n, anything choose 0, always equals 1, which equals a combination of n choose n. All right? Combination of n choose 1 equals n is a combination of n choose n minus 1. Those rules always apply no matter what the value of n is. So if I have the combination of 8 choose 0, that's going to be 1. If I have combination of 30 choose 0, that's going to be 1. If I have the combination of 17 choose 1, that's going to be 17. If I have the combination of 17 choose 16, that's going to be 17. Okay? So certain things come out. And you see that in your second rows here of numbers. Why is all this important? Why do we care about combinations and stuff like that? Because these combinations, these elements of Pascal's triangle wind up being our coefficients in binomial expansion. When I expand a binomial, Okay, we could practice this, but really that's just punching numbers in the calculator. Want to expand a binomial, say x plus y to the 6th power. Okay? The way it expands, the coefficients of my expansion are the combination of 6 choose 0, combination of 6 choose 1, 6 2, 6 3, 6 4, 6 5, and 6 6. We know for a fact that 6 choose 0, this has a value of 1, and this has a value of 6. So this has a value of 1, and this has a value of 6. It's symmetric, always. And if we look back at our Pascal's triangle, it goes 1, 6, 15, 20, 15, 6, 1. So my coefficients come from Pascal's triangle when we do that binomial expansion. Now, the other thing that goes along with that are the terms themselves. And notice what happens. We start with just x to the 6th, y to the 0, which doesn't work out. Then x to the 5th y. Then x to the 4th y squared. X cubed, y cubed, x squared, y to the, whoops. X, no. Really? Okay, fine. And finally, y to the 6th. So our terms have to come along as well when we're doing that binomial expansion. So this is our final polynomial that we come up with the expansion without having to do any FOIL. I mean, our other choice for this type of binomial expansion is taking x plus y times x plus y, FOILing that out. And then taking that product times x plus y. Then taking that product times x plus y. Then taking that product times x plus y. It would take 15 minutes. You'd probably make an addition error during the process. This is way, way faster. It's easy when there are no coefficients on the terms I'm expanding. When there are coefficients on the term as I'm expanding, it's a little trickier, but it's not bad. It just takes patience and practice. So let's say I need to expand 3x minus y to the 4th power. Well, 4th power is where we're going to be, so that's 4th power. So that seems to get common. We'll start with combination 4, choose 0. The first one is going to take the 3x and raise that to the 4th power, and the negative y and take that to the 0th power. That should be negative 1. Oh, I'm sorry. Well, yeah, we'll take that plus. I'm going to make that a negative y just to make life a little clearer. Okay. Instead, I alternated signs here, but we can do it this way. Might be easier to see. Okay. So I started with a combination of 4 choose 0, which is 1, times 3x, the first term, to the 4th power. Now that does mean I have to take 3 to the 4th power, right? 3 to the 4th power is 81. Plus, combination of 4 choose 1. What's a combination of 4 choose 1? Anything choose 1 is that thing, so that's just 4. 3x to the 3rd power is going to be 3 to the 3rd power, which is 27, x to the 3rd power times negative y to the 1st power. Combination of 4 choose 2. What is a combination of 4 choose 2? If I'm not sure, I can do it in my calculator, or I could look at my Pascal's triangle. That's going to be a 6. 3x squared is 9x squared, 6 times 9x squared. Negative y squared is just positive y squared. Combination of 4 choose 3, that's going to be another 4. 3x to the 1st power is 3x. Negative y to the 3rd power is negative y to the 3rd. 4 choose 4 is 1. y to the fourth is just y to the fourth. Negative y to the fourth is just y to the fourth. Now we put things together. 1 times 81x to the fourth is 81x to the fourth. 4 times 27 is 80 plus 28, 108. X to the third y, but it's negative because of a negative y, so we'll just make that minus 108 x to the third y. 6 times 9 is 54 x squared y squared. 4 times 3 is 12 xy to the third, but it's negative because of the negative y to the third, plus y to the fourth. And in green, that is the fully expanded polynomial. People are looking like I just performed a trick of wizarding, that came out of nowhere. Just pulled a rabbit out of my hat. I did not, I promise you. Let's do another one. 2x plus 5y, I'm sorry, let's make it minus just to keep ourselves honest. To the fifth power. Okay? Let's set it up. Generally, you want to set these up in 3 steps. First, with just the combinations and the terms, then we do the exponents, and then we write our final answer. So the first term is going to be combination of 5, choose 0. We're going to take the first term, 2x, raise that to the 5th power, and the negative 5y to the 0th power. The sum of these 2 powers on each term has to be the total that we have here. Plus, next combination, that'd be 5, 1. Take the 2x to the 4th power, reduce that power by 1, increase the 2nd power by 1. Negative 5y to the 1st power. Plus, combination of 5, choose 2. 2x to which power now? 3rd power. The negative 5y to the 2nd power. We need extra space, but that's okay. Combination of 5, 3. This time the 2x goes to the 2nd power, and the negative 5y goes to the 3rd power. Plus combination of 5, 4. This time the 2x goes to the 1st power, the negative 5y to the 4th power. Combination 5, 5. The 2x goes to the 0th power, and the negative 5y to the 5th power. Okay. Yes. Go to jail, go directly to jail, do not pass go. Do not collect $200. That's our rule of the day. All right. So we've expanded it. Now we actually have to do the arithmetic. That's the hard part. Honestly, that's the hard part right there. Getting it all written out. From this point, it's just a matter of watching our signs and doing a little bit of expansions. Combination of anything, choose 0, that's going to be a 1. 2x to the 5th power, that's going to be 2 to the 5th power, which is 2, 4, 8, 16, 32. And anything to the 0th power just equals 1, right? Plus, 5, choose 1, that's going to be 5. 2x to the 4th power is going to be 16x to the 4th. Negative 5y to the 1st power is going to be negative 5y. Combination of 5, 2, what is that? 10. 2x to the third power is going to be 8x cubed. Negative 5y to the second power is going to be 25y squared. Positive this time because it's even power. This is going to be another 10. 2x squared is going to be 4x squared. Negative 5y to the third power is going to be negative 125y to the third. 5, 4 is going to be a 5 times 2x times 625y to the fourth plus 1 times negative 5y to the, what's negative 5 to the fifth power? 3025?
3125.
Negative 3125 y to the fifth. Okay, so step 1 is writing it out. Step 2 is expanding the exponential portions of it and writing out the multiplication. Step 3 is finally putting it all together. This is just 32x to the fifth. Plus, well actually it's going to be minus because I get a negative multiplied in here. 5 times 5 times 16. So 25 times 16 is 400, so minus 400 x to the fourth y. So 80 times 25 is 2,000. Uh, 40 times 125 is 5,000. Uh, 6,250. And finally 31. And what is in red there put together is the full expansion of that binomial. Okay?
So that'd be our final answer.
That would be your final answer. It's a little slow. It's not really that hard. It's a little tedious is what it is. You just have to be really careful as you're working it. You cannot rush this process. It does not rush well. We've broken it down step by step for you here. First step, writing it out with the combinations and everything else. Second, actually finding what those numbers are. Third, putting it all together. And really, I think that's just a great way of doing it. Because it keeps you organized, it slows you down. That's always your best bet. Final question we have today. What if I just want the sixth term of 2x minus 5y to the 10th? Well, that's kind of nice. All I want is one term of it. Which term do I get? This is the part that always gets tricky. What is the sixth term? Well, it's a combination of 10, choose what? 5. Why not 6? Because we start at 0. Okay? And let's look back at an example here. This is the first term, second term, third term, okay? Here, and the combination is always one less, so it works. Okay? You're going to take the 2x to a power and the negative 5y to a power. The sum of those powers must be 10, but what are those powers going to be on the sixth term? Well, let's look back for a hint. When it's 5, choose 0, my exponents were 5 and 0. When it's 5, choose 1, my exponents were 4 and 1. When it's 5, choose 2, it was 3 and 2. So the second number is always the same as the exponent on the second term, isn't it? There's a hint for us. So for the sixth term, since this is a 5, that this is going to have to be a 5. Well, and this is also going to have to be a 5, isn't it? For the sixth term. And I would just do that particular term.
How did you get that the 2x is going to be raised to the 5?
Well, because I knew this one had to be raised to the 5, right? Because the second number has to match here.
Right.
And the sum of these two exponents always has to be the total exponent.
Oh, okay.
Okay? So 10, combination 5, is 252
Thank you.
times 32x to the 5th times negative 3125 y to the 5th. So 252 times 32 times negative 3125 is new negative 252,000,000. So 1, 2, 3, negative 25,200,000. X to the 5th, y to the 5th. That's the sixth term of that expanded polynomial. Of course, our other option would be to actually FOIL that whole thing out 10 times and find what the sixth term is and hope we don't make an addition mistake during that process. I think you see the power of doing the binomial expansion. It's really a huge shortcut. Now, a true shortcut would probably program a computer to do it, put a button, right? But somebody's got to program the computers, yeah.
Where did you get the 252 from?
Combination of 10 choose 5?
Oh.
Mm-hmm.
Wait, how do you know that one? You have to do that whole pyramid?
No, that's for the calculator.
Oh, yeah. Okay, never mind. We're good.
No, I didn't do the pyramid. Oh, that would get long. The whole point is we're making it short, the process short. I mean, yeah, we got a huge number, and that would be ugly to find, but with the combinations and permutations, we can do that. So again, remember, since it was the sixth term, that's an n minus 1 there, okay? And then this number is the same as this number. Oh, it doesn't want to write. Same. Well, my highlighter doesn't want to be curvy. It wants to do straight lines. I don't know why.
And then the 2 always equal.
And the sum of these two always equals whatever that is. Okay? Honestly, practice this a bit. You've got the homework assignment. If you don't practice it, if you try to do this based on just what you watch me do right now, you will fail miserably probably. It won't be pretty at all. But if you practice this and then come back with some questions tomorrow, we look at it a little bit more, especially before school tomorrow. At this point, it looks like I will be here tomorrow, so unless something changes radically in the next few hours, I should be here tomorrow. So I will be here before school for extra questions and extra help on combinations and permutations, because we're going to teach the new section tomorrow too. For those who are going to be in the Milwaukee Zoo, remember it's really expensive. You're better off just staying here. They don't open until like 10 anyway. Don't forget the zoo interchange, I think, is still closed down there in Milwaukee. If you're taking 94 in, I believe that exit might still be, that ramp might still be closed. So you might be best getting off on Moreland Road, heading up to Blue Mountain from there, and past the mall, and driving in Blue Mountain that way. If you don't want Milwaukee, it can get a little bit hairy down there by the zoo interchange, because they were working on it last time I was down there a few weeks ago. It was a mess. Just saying, Moreland Road exit, if you're heading to the zoo tomorrow. When you get off there, hang a left, go up a couple blocks past the mall, right on Blue Mountain to the top. Take you right to the zoo. A few miles down on Blue Mountain, but it's a nice drive. It's easy.
It's like,
But of course, you can get those directions from me after class tomorrow too. That would be just